Hello. Happy Tuesday. How you doing, Nina?
Pretty good. Yeah.
Pretty good. I was hearing the countdown music and then I realized I didn't pause the YouTube videos.
Oh, nice.
But yeah, it started great. Anyway, Hoot number 66, Pie in the Sky, Edge Workloads and Istio Ambient Mesh. So this is what we'll talk about today. So Istio supports connecting traditional workloads that are running outside of Kubernetes to the mesh. And what you can do with those workloads is you basically get all the benefits of standard Istio features like observability, traffic management, right? Different traffic policies and management, security, and so on. So with me today, I have Nina, and Nina will be showing us how to onboard a workload running on the edge on Raspberry Pi, right?
Yep.
And onboard it actually into Istio Ambient Mesh. So there's going to be 0 sidecars.
Well,
right?
we're going to have a couple sidecars just
to sprinkle them a little bit, so it's not just pure ambient.
Yep.
All right. Well, as always, if you're here, say hi. If you have questions, feel free to ask them at any time.
Yeah, I can take it away.
Take it away.
Actually, some backstory on this. It's kind of the same demo Marino and I did for the co-located Edge Day at the last KubeCon in Chicago. So it was like a 30-minute lightning talk. So we had a lot of prep that we did beforehand, and not everything made it into the demo. Plus, like we had some, fun live debugging that we had to do. So we only were able to show like a subset of the features that we wanted to. So this is kind of like a behind-the-scenes like tour of all the fun demo prep we did, and like a little more deep dive into the different policy configs that we're going to use. What's happening on the Istio side and stuff like that. So I guess
are we also doing any live debugging?
That's well, hopefully not if the demo gods are nice today, but if we do, that's okay. That's part of the fun. So
yeah.
Okay, so I'll share my screen and entire screen. Yes. So cool. Can you see my screen?
Yep, I can see it. Let me just find I think that's fine. If the fonts are too small, let us know and we'll make it bigger. Looks good to me, but we'll see.
Yeah. So this is, if you're familiar with onboarding like VMs or like legacy workloads into Istio, you're probably familiar with this. This is part of a guide that I think Nick wrote a while back about onboarding VMs. The only thing I changed is the Raspberry Pi here has replaced the VM. And it's kind of what I'm going to do today at the beginning of the demo, is just to onboard it. So there's a lot of steps, as you can see. There's some stuff that happens on the Kubernetes cluster side, and then some stuff that happens on the Raspberry Pi side. And the user, in order to onboard like a legacy application or Raspberry Pi or VM, has to do all of these steps kind of in order to get the Raspberry Pi fully integrated into the mesh. If you don't need the Raspberry Pi to be fully integrated, you can do like a one-directional onboarding where your like Istio service mesh can reach out to an external workload using service entries. But in order for the Pi to be able to communicate to the cluster and the cluster to the Pi, which is what we're going to show today, you kind of need this whole onboarding bootstrapping process. So, and this again, like for context, is going to be in a single network space. If you wanted to, we're going to briefly talk about how to do this in a multi-network space, but the demo is going to be in my home setup. So it's just using my local.
You only have one network at home?
I know.
But the difference here is, right, if it's one flat network, right, then you don't have to, like, it's all the same, like same address space, I guess.
Yes,
right?
Exactly. Yeah. So because it's the same address space, like everything on our cluster, which is just going to be a kind cluster, is going to be able to talk to everything on the Pi directly because it's all like on the same network. Mm-hmm. But if you have multiple networks, in addition to exposing Istio-D, you'll also have to expose your services. So everything will have to go through your ingress gateway or like your east-west gateway to be able to communicate to each other. In this setup, only the XDS traffic is going to go through the east-west gateway that we have set up, and that's why we have to create a gateway and virtual service to expose Istio. So I'll point that out in a bit.
And XDS traffic, that's the configuration.
Yeah, so that's the control plane configuration. So like all of your virtual services, all of your gateways, your destination rules, like once they get configured, the control plane has to send it out, to all the sidecars in the mesh or all the Z tunnels in the mesh. So that's the traffic that's getting sent over XDS. I think it starts like X is just like X discovery service.
Anything, yeah. That comes from Envoy, right?
Yep, exactly.
Yeah.
And then the other thing we're going to do is create a service account on the cluster side. So this is how we're going to identify our Raspberry Pi in our mesh. There's a nice nifty istioctl command that kind of does these two things. And then finally, we're going to create a workload entry that, because we're going to use an ambient Z tunnel running on the Pi, there's a couple changes that we have to do to the workload entry to actually get it to work in our setup.
And the reason we have to create the service account is because we're basically straddling the Kubernetes space, and then outside Kubernetes space, in this case Raspberry Pi, and we use service accounts to
create a token. Yeah, so we're going to
basically give an identity, right, to the whatever's running outside of the cluster.
Yep, exactly. So this service account token, it's kind of foreshadowed in step 4. We copy the service account token and use this as the initial like short-lived JOT token that's going to only live for like an hour, and bootstrap it with the mesh. And then we're going to copy over all the config files that we need to like run our Z tunnel, make sure our Etsy host is set so we can actually reach the east-west gateway correctly with the Istio SNI. And then finally, we're going to run, not Envoy in this case, the tunnel in this case, but from our .deb file, because the Raspberry Pi is going to run Raspbian, which is very similar to Debian. So luckily, everything works with the Z tunnel I built on that.
Yeah, one thing on the, like, if anyone who's watching, if you've ever like tried to onboard the VM workload, right? One thing that can trip people up is that 1 hour expiry on the service account token, because like if you're taking your time and slowly going through everything, and you take a coffee break or whatever, you come back and it's not working.
It's not working, and
make sure you refresh the token.
Yeah, and I think I misspoke briefly. The config files here are like the config to run the Z tunnel or run like the sidecar in the classic case. For the service account is what's going to be used for the initial bootstrapping. So the Z tunnel or the Istio proxy is going to reach out and then do the CSR request and copy the certs over. These config files are like more like, okay, what are you using for your C address? Like
high level meshy stuff in a way, not necessarily the sidecar or Z tunnel stuff, right?
Yep, exactly. Cool. Okay. And then, so in our setup, I'm just going to give a high level overview. So this was like kind of what we envisioned very ambitiously for our first demo. And then we kind of scaled it down to just highlight the ambient part. But everything I'm going to show you today works with a sidecar running on the Raspberry Pi as well. It's actually not that interesting because it's a little easy. You just get the release, like Istio now releases ARM-based .deb and .rpm files, right? So you can just grab the Istio version of that, run it on your Raspberry Pi without any issues, and it works both in like the single network and the multi-network case. So like I tested this with like a GKE cluster, and then had like my local port forwarding set up and my Raspberry Pi on my local network, and it actually worked like relatively straightforward. So I thought the Z tunnel was a little more interesting because it also highlights like some of the benefits that you get with Z tunnel, because your Raspberry Pi is compute constrained. Like you can't build Envoy on your Raspberry Pi. There's like a lot of limitations.
I can't build Envoy on my laptop, let alone.
Yeah, I can. I mean, I have like a nice M2, and I still can't build Envoy on my laptop. So, yeah, but Z tunnel, actually, the Z tunnel we're going to use, I built it on the Raspberry Pi, and it took like maybe 15 minutes. So it's pretty fast, and much better than like dealing with Bazel and all the Envoy nonsense.
Yeah. Yeah, that word triggers something in me. And I haven't spent a lot of time with it either. So it's
Yeah. But yeah, in this case, we're going to be running a, well, I guess first let's show the cluster setup. So I've been testing this out earlier today. So you can see 3 hours ago, installed Istio and like set up all the example apps. I just have a single cluster setup. It's a kind cluster running on my very old Linux laptop that's running 1804, just because the networking is a little easier if you're running like on Linux instead of Mac, because you don't have to deal with Docker shenanigans.
Yeah.
So this is I'm SSH'd in and running kind here. This is K9, so you can see the everything in like one nice view. So these are all the pods that we have. And you might notice that we have, like I mentioned, Istio already installed. So this is Istio D. Here we have our east-west gateway. So I mentioned this is the east-west gateway that's going to be responsible for all the XDS traffic going through it. So all of our like updates, if we like bring up example apps or like take them down or like apply config, that's going to go through the east-west gateway. Then since we're running in ambient mode, we actually have a ztunnel installed. So we only have one node for this example because it's pretty straightforward. We don't have that many apps. We're just showing like basic ambient functionality. And then we also have the Istio CNI. So one thing that I do have to note is when I did this demo, this was in November. So we were like prepping early October. And we're using a slightly older version of Istio. So this is 119.3. So it doesn't have all the fancy stuff that just got merged in with supporting any.
Oh, yeah. That got, but granted, that's not. I mean, got merged in, but it's not released yet necessarily. But yeah.
So this is a couple versions older, but it still works. At one point, like when I have more time, I'll try running it with the latest Istio version, but I'm not expecting anything to really.
And then, I mean, if you do that, then you could also install like Cilium CNI if you want to, right? And layer it in on top. So
yes, so that would be very cool. But not for the old.
Yes. Yeah.
But, so and then like I mentioned, most of these things like sleep, for example, don't have sidecars, but they are in the mesh, because if I look at like sleep's running in the default namespace, I have it labeled Istio Ambient. I have a mix of different applications just to test out different things. Like I mentioned, like this initial demo setup kind of assumed you could run both the ztunnel and sidecar on the Raspberry Pi. So in order to show that, I kind of have a mix of both. So like Not Sleep, for example, does have the proxy injected. The Hello World also has the proxy, so we can apply some L7 policies there. And HTTP bin is also running just HTTP bin. So, but I have labeled that as ambient as well. So you can see that HTTP bin also has the ambient label there.
See, one of the things that was nice with the sidecar mode is you could tell right away which pods are part of the mesh, because there's always 2 out of 2, right? But now you actually have to check the the namespaces and the labels.
I think there might be an istioctl command that helps you do that, but it is kind of annoying, like going back and forth to be able to see this. Is like just like But I think the benefits still outweigh not having to.
Oh, of course, yeah. I'm not saying don't stay with the sidecar mode just because of that.
Cool. Okay, so then I mentioned we have to expose Istio D. So in order to do that, first we'll briefly look at the services. So I have Istio East-West Gateway. Since everything's a flat network, we're actually going to use the cluster IP, because I've exposed the pod and service siders on the Raspberry Pi to get routed to the Linux kind cluster. So we're just going to use the local cluster IP there. But I'll point that out when we get to actually configuring stuff. And then the two things that we need in order to expose Istio D is first a virtual service. So Istio virtual service is kind of responsible for the routing logic that configures things, right? So like in this case, we're exposing our Istio. So this is the gateway that we have
Attached.
attached to it. Yep. We're letting everything through just because it's this is the example that you usually use for the VM onboarding. So I just kind of copied that. You can definitely limit that, but like it's for this, like since we're just sending XDS to like IstioD, that's kind of fine. And then this is again the Istio control plane that's running. This is the port that we're using for discovery, and yeah, so that's our virtual service. And then let's take a look at the gateway.
Yeah, so it's basically attaching virtual service to that gateway, and then saying matching on specific ports and all SNIs, and then routing to IstioD on 15.0.17, and then well, one is 12, and then the other one is 17. Which is both of them are just passed through, right?
Yep, exactly. Yeah. So both of them are, this is the gateway that we attached our virtual service to. So they're both pass through. Again, this is the discovery port that we care about. And this is the label on our east-west gateway. So that's how we're selecting that service there. Cool. All right. So so now I guess let's take a look at what I did to actually onboard. So as part of the demo that we did at KubeCon, we created this demo repo with all of our scripts. And before this, I've kind of run through kind of setting up the kind cluster. I set up the networking. So again, like I mentioned, this is a flat network. So you can read through the manual steps, like I'll send this in the link, but we want to make sure that our host machine doesn't, drop any things coming to it. So we're setting up some IP forwarding. We're adding a route rule to make sure that we can reach things running in our Docker container on kind, right? So we're like all of our pod and service siders are going to go through our node IP, which is our Docker node IP, right? We are then on the so adding a filter to forward. On the Pi side, we have to add this route. So again, since it's a flat network, we're going to use our Pi has to reach out to the east-west gateway and our services, right? So in order to do that, we need to add a rule so that anything in the pod and service cider can go via the cluster address of the Linux computer to actually route the traffic correctly. So we're adding this very simple rule to match on 10.0.0.0 via the Linux,
whatever the IP address is of the cluster.
Yep. So that has already been done. So we can test that if just to sanity check, this is the thing that was messed up the last demo is that IP route rule that I just showed actually
was missing, or
so the thing is able to connect. So we started the Z tunnel, and then we weren't getting any updates, and we're like, oh no, what's happening? So an easy way of testing that is we can just grab one of the pod IPs, get to our Raspberry Pi. You can see I was testing some stuff earlier. And so I'm SSH'd into my Raspberry Pi, and I'm just going to ping one of the, nope, that's not, what's the IP? This guy, yeah. Okay, cool. Oh, nope, just move that to the side. Sorry. Okay, so we're going to ping the thing, and we are getting a response. So that means our IP route is there. If we do just a sanity check, we can see that this guy, so all the pod and service siders are going via this local IP. And if I go back to the kind cluster and I do you can see that this is the IP of the Linux
of that machine. Yeah.
Cool. So that should be connected. Actually, I'll kill the Z tunnel because I was running that also earlier. No spoilers. Cool. Okay, so we can ping. So now the Z tunnel is dead, so we're gonna try re-onboarding. And it's been 3 hours since I ran this, so it probably the key has expired. So
yeah.
So in order, let's go back to the walkthrough. So I've installed Istio already. We walked through all of the example apps that I have. So the next thing is actually onboarding the Pi. So we have to create all of that config I showed, copying the service account token, copying the config files, all of that on the Raspberry Pi side. So in order to do that, I have a nifty command called Istio onboard Pi. So we can take a look at what that does. Extra line. So given the Pi address and username, like this obviously switched when we were in KubeCon versus my home versus like when we were in the office testing stuff. So can't hard code that, as I've learned.
Yeah.
But we're gonna so there's two ways of doing this, either initializing ztunnel or the sidecar mode. So this is just some logic to check what mode we're running. This is some stuff that's going to go in the config files that we have. So just like what namespace we're going to be in, like what's the name of the service account, things like that.
So we're basically creating a representation of the workload that's going to be running on Raspberry Pi inside of the cluster itself.
Yeah, exactly. Yeah. So this is going to create all the representations on the cluster side, and then it'll also at the end of the script copy it over to the Pi. So it kind of does like this whole flow that I talked about earlier in one script.
Yeah.
So it's very hard to mess up, hopefully.
Yes, hopefully if it's just running the script, it should be fairly straightforward.
Yeah, so I definitely didn't want to do this like one step at a time because it's like a hairy process. So we create a workload group. And unfortunately, like, so usually when you're onboarding VMs, like for sidecar mode, this actually works relatively well. So you can use auto registration to, based on the workload group you define, create, like have Istio auto register your VM when it reaches out. Unfortunately, it wasn't working for the ambient labels. So you're going to see our workload entry. We need to have this ambient redirection enabled. Otherwise, our application running on the Pi is just going to get trashed.
Okay, so that single line there, that label is like you could have used the auto-generated, but you're not going to get that.
Yeah. Right? So yeah, for the like running like the sidecar mode, you actually can. It just and then this is just like in case like I don't think you actually need this part but we're doing is more of an example of like what it
what's the difference. And the auto registration thing is, so workload group you could think of as a Kubernetes deployment in a way, right? And then workload entry is like pod in a way, right? So when you do workload group and with auto registration, right, it's going to actually, Istio itself is going to create the workload entry for you, is going to populate the names and namespace, including the IP address.
Yeah.
Right?
So like we can take a look back at the workload group. The workload group is like a higher level representation. So once the Pi, like if you have auto registration enabled, if the like VM or Pi or whatever workload reaches out, when it does
the trigger, right?
It creates the workload entry. Yep.
Yeah.
So like all of these things that you define on the workload group are going to get inherited by the workload entry that gets like auto created by Istio.
Yeah, so it's like a template for the workload. Well,
exactly.
It is a template because there is a field called
literally template. Yeah. So cool. Okay. So so and then finally we're gonna copy everything over to this file called Pi files, and we're good to go. So let's try. Let me see if I can find. I ran this earlier. Nope, not that one. Istio. Yeah. Okay. So pretty sure this is our Pi address, but let's sanity check. I'd rather not. Let's hostname Pi. Yep. So this is the Pi address. So now we're gonna right. This is my. Okay, so we're running the script we just walked through. It's copying stuff over. And you can see we copied over hosts. Like this is the thing that's going to go into etc hosts, cluster env, root pem. The mesh. Both of these are just like a config on like how to run the like sidecar or ztunnel. And then finally the Istio token, which is what we're going to use to actually do the initial bootstrapping.
And these files are generated by that workload entry create command, right?
Yes, the SQCTL. Yep.
Yeah.
Cool. Okay, so then let's go back to the Pi side and try starting the ztunnel. So first, let me double check that it's not running, right? So ztunnel is no longer running. I've port forwarded 15,000 to like when I SSH'd in, you can actually SSH in with, let me this command.
Oh,
So
yeah, to port forward.
forwarding from my local Mac to where the
Whatever,
ztone is going to run the admin page. Yep. Let me just get there for. Cool. Okay, so I'm in setup ztunnel. So the next step, if we go back to our like run through, is on the Pi side, we've already copied over like this directory that has all the setup logic. And now I'm going to run, not in sidecar mode, in ztunnel mode. I'm going to run the script. So let's take a look at what that's going to do. So again, there's some logic just to find the Pi internal IP, so we can set that correctly. We need the Istio east-west gateway. So this is what I pointed out earlier. Like we'll have to look back at our services and get the cluster IP to provide that, because that's what we're going to use to set Etsy host to be able to actually like reach out and talk to Istio. Let's see what else. We have some IP table rules. So this is one thing to point out. So in the repo, I have, we go all the way up. I actually have steps on how to do the like building of the ztunnel on for ARM. But unlike the nice packaged Istio sidecar, it doesn't have the setup, like Istio setup script that does all the IP table rules and whatnot. So you have to apply the IP table rules yourself. So this script that I have here is actually applying the ztunnel IP table rules that the setup script usually does, or the CNI usually does. Like setup script for if you're like onboarding a workload or VM with the like regular Istio like sidecar .deb or .rpm file, then it kind of like you don't have to manually apply any IP table rules. But for this, I copied the IP table rules that ztunnel was using at the time, and I had to add a little one of my own in order to enable DNS. So you can see that we're adding a rule for UDP traffic going to port 53 is going to go to our Pi DNS server instead of ztunnel trying to resolve that.
Yeah.
Cool. And then finally, we're going to, like, since I've already installed it, we don't have to reinstall ztunnel. It's already installed based on the, this is what's in the repo that you can build yourself with the Rust.
That's the thing that takes 15 minutes.
Yeah,
right?
Yeah, exactly. So it's very quick, or you can just clone it and use the one I pre-built. But you can even build it on the Raspberry Pi, so no need to have any fancy machinery. And then finally, it's going to copy over some files into the right place. And then we are going to add to Etsy hosts. I think this is yeah.
These are all like I remember when I was doing VM onboarding. These are all the same steps. Basically, whatever files we copied over, we have to just put them in the right folder and right place, so the ztunnel when it starts knows where to look at.
Yeah. So this is one thing to point out is this is a lot of manual work. So I know on the platform side, the latest 2.5 release has a lot of nice things that like automate this process and actually integrate with Spire, so you don't have to do this let me copy this file into the right place. But since this was like an open source talk, we're like everything we're using today is open source.
When you said platform, you meant Glue Mesh.
Glue Mesh, yes.
Glue platform, yeah.
Yeah, so there's a lot of fun like features that were added in the 2.5 release that make this process like automated with Spire and just like one command that kind of does everything for you.
Yeah.
And that's really cool. But for this one, again, we're just using plain old open source Istio, but it's still like.
I mean, it's honestly, it's good to know, right? What goes into making the sausage in a way, right? Yeah. So you can see all the like details that you have to think about, because that way, at least for me, that way you like if something goes wrong, you know at least where to look at, right? Yeah. If nothing else. But yeah.
Yeah, and this is the last thing is we're just echoing the command. So if we weren't looking at the file, just to highlight, this is what's getting run. It's going to be a little noisy because I have the Rust log set to info.
Okay, so it's going to show.
But that's okay. That it'll also show us like when things hit the ztunnel. So
So this sudo u Istio proxy is actually running the Z tunnel,
Yep.
right?
So,
As a parameter, right?
Yep, exactly. So when we unpackaged it earlier, so this is the same setup that again, like if you're familiar with the like VM onboarding docs, like this command you run with the like Istio sidecar. Instead, we're just running it with the ztunnel that I build.
Yeah.
And then like once that's unpackaged, then you can run it directly. Cool. Okay, so let's try that. Let's see. Yep. Oh, well, okay. So this, hopefully this was right. We're going to take a quick look. So this is the east-west gateway cluster IP. So we jump back to our cluster.
Because that one is needed because for the host entry, right? So it knows how to, So it knows how to resolve STOD system, blah, 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 right?
Yeah, so this is,
the IP
added to our Etsy host. So we'll take a look after we run it, but this is, like, we don't know how to resolve the STOD Istio system without it.
Yeah.
Yep, okay. Oh, it started. It said for me. Cool, okay, well, timeout, something happened.
Oh, timeout, there we go. Yeah.
Okay, well, okay, let's try, we'll run it one more time and apply the rules this time. Okay, cool. So we're running ztunnel now. You can see like all of this config is what came from the config files copied over. So like our workload name, like the namespace, stuff like that. And let's take a look at the Etsy host file. Okay, so this, before I was using the setup, so you can see it got added a couple of times. But we need the east-west gateway address in order to resolve this.
But I think that's the only reason why that IP is needed, right? Because ztunnel is going to call that Istio system.svc, not the IP. Right?
And traditionally, like this shouldn't be the cluster IP. If you're running in like a real setup, this should be the load balancer IP that like
the external one, right?
Yeah, exactly. Cool. Okay. Well, now let's see if it actually worked. So if I go back to the admin page, so if you're not familiar, this is the, let me pump the font size. This is the new ztunnel admin page, and it should have our config dump here. And hopefully, it looks like we got some things from the
it recognizes, well, the ztunnel running on the Raspberry Pi received the configuration about the workloads that are running in the cluster, right?
Yeah, exactly. So like Hello World was running on the cluster, HV bin was running on the, I can't spell, it turns out, but HV bin was running on the cluster. So now our Pi should be able to phone home back to the cluster and hit these without like hitting the IP directly. So like before, when we pinged the pod IP, that was all nice, but we actually want to do like hostname resolution, right?
Yeah.
So if I go back to the Pi, right, and I do like hello world namespace. Yeah, I always misspell like when I'm typing live, but okay, cool. Yay, we get 200. We can do it a couple more times because there's two, so we get v1 and v2. And if you look at our very noisy logs in the ztunnel, you can see that we're querying for hello world. We know that it's in the mesh, so we're using hbone and getting a response back.
Awesome.
Cool. Okay, so now that's all nice, but let's see if we can apply some off policies to it. So part of the demo that we didn't get to actually in KubeCon was applying policies on the cluster side and showing that the ztunnel has to respect them. So one of the policies that is fun to show is the off policy, because it really highlights the difference between L7 and L4. So we're first going to apply a L7 policy to Hello World, and we're going to allow only things from the Raspberry Pi. So this is a service account that was created by IstioCTL like X workloads onboard, right? If it has the Istio is cool header. So before we were hitting everything, like there's no off policies in place, so we were able to hit Hello World like normally. Now we're going to restrict our access. So unless we have the Istio is cool header, it's not going to be able to go through. So like a silly example, but it kind of shows like an L7 off policy working in place, right?
And this is L7 against, is Hello World running an ambient, or is it a sidecar?
No, so this is sidecar
Sidecar,
mode.
right? Yeah, yeah,
It's
yeah.
kind of like a heterogeneous like mesh setup
Yeah,
again, just to show like we were very ambitious and wanted to show both like
yeah.
ambient and sidecar on the Pi. But if you like, I think in a fully ambient setup, if you wanted this policy to work, you'd want a waypoint in place instead, because the sidecar like it really like you need a sidecar per pod versus the waypoint can be per namespace or per service account, so it scales a little better. Like a lot of the times you don't necessarily need like all of the L7 policies that you might think you do. Like so, if you're not doing off based on headers, for example.
Yeah,
Like
any HTTP stuff. That's how I say it. Any HTTP stuff requires L7, meaning in ambient you will have to deploy a waypoint proxy.
Yep.
And anything L4, anything below L7 and L4 stuff is handled by ztunnel. Right?
Yep, exactly. But in our case, like the sidecar is gonna, like the policy is gonna get picked up and applied because some backstory too, like authorization policies are always going to be enforced on the server side, right? Because it'd be kind of silly having a client enforce an auth policy.
Yeah, on the other, yeah.
So all of these policies, like both the L7 one that we're going to apply now and like the L4 one, are going to be applied like at the server side. So the Hello World sidecar is the thing enforcing it.
Yes.
Okay, so let's go. There's too many Hello World policies. Okay, so we created that. So now if we go back to our Pi, and let's do the same curl as before, we get
not gonna work.
Yep, so RBAC access denied. We can try it again, same response. And you can see that the ztunnel is actually like fine letting it through, because on the client side, it's like, yeah, sure, like I know how to route you, but on the server side, it's like no go.
Yeah.
But okay, that's kind of sad. So let's try adding the header and seeing if that now makes us happy. I'm gonna mess up the spelling of it, right? Let's go back and copy it over. Yeah, so X test, okay.
So with this, basically, we're saying the only calls that should be, the only requests that should be let through are the ones that have the X test header set to Istio school value.
Yep. So you can see that we're getting our 200 response, that we're using the Istio school header, but like any other header like is not cool. You get denied.
Yes. Yeah. Not cool headers get denied.
So that's like the direction like Pi to the cluster. So like pretty cool. You get HBone for free because the ztunnel is running it. So like the connection secure. So now we're going to go in the opposite direction. So I guess before we do that, I've been saying that this is a Pi, and like you can see it here, but we can take a look at what's actually running stuff here. So for the demo in November, we used an LED strip connected to our Raspberry Pi. So this is the little Pi that's running our ztunnel right now.
And you have a box for it. All my Raspberry Pis are outside.
Well, this was a recent acquisition. Like I usually don't have boxes for my Raspberry Pi, but I was a little worried that like it's gotta transport it, like
Oh yeah, hazard. Yeah.
And then so the LED strip is just the NeoPixel like what's it called, the WS2812 or something. So there's a lot of open source libraries that like let you program it. This is connected to the pin on the Pi, pin 18, I think. So the data pin here is super flimsy, but it can connect there. And then you have the 5-volt power connected to our little switch box. So this was the part of the demo that we didn't actually get to show anyone, because it's, first of all, like it's kind of hard bringing all of this bulky stuff to KubeCon. But when we were in the office playing around, we had a tea kettle, and I brought this MSN switch from home. So we had some fun making like fun teapot related policies. So this is, like I mentioned, a programmable switch. So it's connected to an Ethernet. So the same network. And I can run a server from the Pi that uses the MSN switch APIs to control the two lights, like light 1 and light 2. And then this is a random teapot I have from home, but it's just there for aesthetic purposes. Like it like will beep when the power goes on, but other than that, it's not like a super smart teapot. So unfortunately doesn't, automatically make tea and whatnot, but
Yeah.
it's enough for demo purposes. Cool. Okay, so like I mentioned, everything like this is running on the same network. It's connected to the Wi-Fi, and the LED strip is connected directly. And then this is the Pi will control this via the API, and it's on the same network as well. Cool. Okay, so going back, let's try running the switch server first. So I have, we're going to run like a simple Python app on the Pi and then send traffic from the cluster to the Pi. So in order to do that, let's get this one. Switch, actually, I need my history. Okay, well, I'll have to look up the IP. So this, I think, needs the IP of the MSN switch. So I have this, again, like I mentioned, on the same network. So you can see right now.
That's just the outlet, right?
Yeah, that outlet. This is usually used, like, again, it's kind of overkill using this for team, but it's like usually used to like power reset the, like for, your modem or your router. You can remotely do a power cycle. But today we're going to use it for tea because it's like a
why not?
Why not? So yeah, so this is the IP I'm going to provide. It needs to be able to reach it, right? So oh, not Python. It's not a script. That's why I couldn't find it earlier. I see. Okay, cool. So we're running it on port 80. And actually, in order to get this to work fully with our setup, we need one more step. So like I mentioned, we have our workload entry that selects a service account. And this workload entry is called Hello Pi, right? This was created by like the onboarding step I showed earlier. And related to that, we have 2 example services that I created in order to actually like add, you can use service entries instead of services, but Istio needs like a way to recognize like this is an app I can talk to, right? So for the teapot, I added one that is, again, using the workload entry, Hello Pi, right, that I showed earlier. And it knows, like, we have to say that it's running on 80 to actually be able to hit it.
So basically, so you have to create a service because you need an actual name that you can send requests to, pretty much, right?
Yeah,
that's
exactly.
where
Yeah, so like I could hit like the IP directly, right, and the traffic would still get captured by the Z tunnel. But I wanted to be able to use a nice host name and like actually
stable name, right? That's what they say for services, right? You need a stable name that you can access this.
Yeah, so this is what we're using for the teapot. So it's going to be running, the name of it is teapot Pi, and it's also in the Pi namespace. So and selecting the workload entry we should. Okay, so let's go to one of these, like not sleep, sure. So this has curl in it, so we're going to go from something in the cluster and try hitting the Raspberry Pi. So I think it's teapot, can't spell, in the Pi namespace on port 80, and we'll turn switch 1, sure, on, make it verbose. Oh no. Okay, let's see.
We'll be debugging. We'll be debugging.
Okay, let's see. Maybe. Okay, let me go back and double check that I have the
endpoint. Maybe it's the endpoint.
The name correct. Yeah.
Oh, switch. You misspelled switch 1, switch 2. You had switch on.
Oh my god. Yeah.
Yay.
Okay, so
you did switch 2. Yeah, there you go.
So we can see that the light went on. So that's now
on. Show us again. Show us again.
Yeah. So
I was too slow to switch.
Yeah. So let me try the first one. So we'll see the tea go on. So we have a teapot.
Nice. Boiling. We're boiling.
We're boiling. So yeah, so now that's all cool, but we want a secure teapot, right? So because we're running ztunnel, we can do an L4 policy to restrict who can talk to our teapot. So if we go back to our policies, the next thing we're going to apply is an L4 policy on the Pi side. Or let's take a look at it first before I randomly apply code. So this one is super simple. It's kind of the inverse of what we had before because it's a deny policy. So anything coming from sleep going to our hello Pi like workload entry is going to get denied. So if we go from not sleep, we should still be good. But if we go from sleep, we're going to not be able to.
It's not gonna work. Yeah.
So let me apply that. Great. Okay, and then if we go back, so again, this is I think we're not.
I think it's not sleep. Yeah.
So this should be fine still. So we should still be able to hit our switch. We still get our connection. Both of them are on. Nothing's really changed. So let's try turning off like switch 1. So it's off. So the T's sad. No T for us, but. And then if we go to sleep, we do the same curl. I think I copied it right. Yeah. No, wait, I'm going to copy this time because I've learned from my mistake. So this should, so we get a receive failure. So this is slightly different from the for a 3 response we were getting back earlier. And again, this is like, it's the same like forbidden like authorization denied, but because the ztunnel is running at L4, you're not getting like a nice
you're not getting an HTTP status message back because yeah. But if I think in the ztunnel logs you'll actually see a 403.
Yeah.
I think it's gonna say RBAC denied or something. Right?
That is a great point. RBAC rejected.
Oh, so, RBAC rejected. There you go. Yeah.
Before that, we were going through correctly, and here we're getting rejected because our service account is sleep.
Sleep. Yeah.
Yep. Okay. Cool. I guess we have time for.
Of course.
A little more. Yeah. Let's
of course. So let's
do one more policy, and yeah. So the last thing I wanted to show was in. Which one? Okay, let's take a look at it again. So we're gonna add a fault injection to our teapot. So the reason I'm using a teapot is like when we were planning this demo, I thought it would be funny to have a fault injection with 418 because it's like a great networking Easter egg. So if you're not familiar, it's like 418 was part of a RFC that was published as an April Fool's joke back in like the 90s for this like coffee pot protocol, and it's used a lot as like a Easter egg or joke. And now that we like literally have a teapot connected to our ambient mesh, it feels very apt to use Istio's virtual services.
The stars have aligned. The demos
Yeah.
are aligning now.
Yes, the demos are aligning. So again, like I think this is one of the coolest things about Istio is like you don't need to change anything on the application side. You just create this network policy and you get this like response for free. And like you can test like in the real world, like fault injection is great for like testing fault tolerance. You can add response headers like I'm doing here. And it's just super powerful, like changing behavior without actually changing the underlying application.
Yeah.
So so we're going to apply this. This policy is going to, if I have the header tea drinker Nina, we're going to get a 418, but everyone else can go through and hit the default route. So those are the same like hosts that we were using before. So let's try that. All right. Okay. So then if we go back, let's not use sleep because we know that that's blocked. But if we do this from before,
should work.
Should work. And now if we add header, I think it's tea drinker Nina, we get
filter aboard. Yeah.
Like,
and I think you added the you added the response header as well, right?
Yes. Yeah. So it's 418. It's unknown because I think whatever library Envoy is using doesn't have the teapot status, but we added a header for that. Right,
anyone watching, you can go to Envoy repo and open a bug and say to add
Demanding
the
418.
418. It's in the spec.
Yeah. What else? I think another thing to point out, like, well, we have 10 minutes, is like this is running only one application, right? So I'm just running the Teapot app. But anything running on the Pi is like now onboarded, right? Because it's not like it's not a pod that has like a sidecar injected, right? It's like any traffic incoming into the Raspberry Pi, like or VM, is getting captured by the Z tunnel running there. So if I do like this, like if I'm SSH'd into the Pi, and I do the same response as before, like right, I can still resolve like the host name even from the like VM.
Yeah. Because it's Z tunnel, right? Z tunnel is taking everything over, and
Yeah.
you could theoretically run like multiple, as you said, right? Multiple things on different ports if you wanted
Exactly.
to.
So
Right?
this is you're stealing my thunder here.
Oh, sorry.
I don't know, it's good.
I'm
Yeah,
just repeating what you said.
so you can run the LED strip, for example. Well, hopefully everything's
Oh,
connected.
let's switch there.
Yeah, so
You're
we
gonna
have.
move the camera. We'll see it.
Do you see the LED strip? We'll
Yeah.
make it nice. Okay, cool. So this is a slightly different service. So like it's running on 8080, and in order to get it to work, I had to create a different service, like other than Teapot Pi, LED Pi, that is also mapped to 8080. So I think I should be able to hit it from Outsleep. I think I was doing this earlier. Let's see if I have it. Yeah. Cool.
Oh, there.
So if we do it, get our bright lights. And this is our, you can see our nice glue ASCII art too that we used for the KubeCon demo back in.
Oh, that's the response that gets sent back.
Yeah.
Ah, nice.
So
nice.
Cool. Well, that's all I had. I know kind of took up the whole time, but
no, perfect. That's perfect. Mohnish was asking, what is this live stream about? We're getting to the end, but it was about running workloads on the edge outside of the Kubernetes cluster on a Raspberry Pi, and connecting them back to the Kubernetes cluster and making it part of the Istio Ambient mesh, right? So that's what the stream is about. It wasn't about web development per se. However, you could run a web application if you wanted to on your Pi server. Why not? Yes, it's Raspberry Pi. Yes. So yeah, if anyone has any more questions, now is your time to ask. I spoke with Nina yesterday a little bit, and I'm always like excited with whenever there's like Raspberry Pis or any like hardware devices like included in the demos and all that. Is just there's never time or space to play with the hardware a little bit more, but.
Yeah, it's definitely fun to see also like on the ARM side how much development has been made, because I know when I first joined Solo, like someone had built like a glue edge build of like open source glue on a Raspberry Pi. And it took them like a day to compile Envoy, like they were running it the whole time. But now it's like Istio is publishing ARM builds for the sidecar. Like I think there's a lot more support, so it enables a lot more like hacking and like for fun networking things on like
yeah, and it's like have you ever done I've seen a lot of people have done their like run a Kubernetes cluster on like a cluster of Pis, not one, right? They have like a rack of them or whatever. Have you done that?
I haven't actually.
So
this one is also kind of interesting because we're running it like bare metal, right? We're not running like any cluster on the Pi side. But you could do the same thing by like running,
the other. You could run a Raspberry Pi cluster and then have another Raspberry as an external.
Like an external.
Yeah. Well, awesome. A lot of people joined too late. Well, Make sure you rewatch the video. Feel free to comment and ask questions. We'll be monitoring the comments anyway. So yes, a lot of people have done running the Mohnish was saying that he's seen people run Kubernetes clusters on Raspberry Pis, right? Which is nice. Like for me, it's doing that. That's great, but it's also like the possibility of, like, you had a teapot, right, and a light strip, and there's like gazillion other like sensors and things that you could hook it up if you wanted to, right? And then have the and you can do like a dashboard or something, right, for your sensors and whatnot. There's like gazillion possibilities.
Yeah, and it's a nice entry. Like it's relatively affordable to get a Raspberry Pi, and like there's so many guides out there that
yes, yeah. You don't have to be an expert. I mean, it's fairly beginner friendly as well, I think, right? It's not, the documentation is really good as well. So all right, well, I don't see any questions. A lot of people came in late, but anyway, this was interesting. I hope you build a Pi cluster at some point, and then hook up more things, and then we'll do another episode. This was it was really interesting to see how I would say how you can use something like Istio, right, an ambient mesh, and even Kubernetes with, like, in an unconventional settings, maybe, right?
And that was the feedback, I think, from the Edge Day too. Like most people hadn't like heard of Istio, or like running a service mesh on the edge, especially like in sidecar mode, like seems like kind of overkill because it's so compute intensive. But now it's like we're going in the ambient direction. I think there's a lot of like potential there as well.
Yeah, exactly. All right, well, thanks again, Nina. Hope everyone liked this. If you have comments, comment. Comment. And we'll be back in a couple of weeks again with a different episode. Thanks, everyone. Bye.
Yep.